Welcome everyone. In this video we will determine the equivalent resistance of infinitely many resistors. I know that sounds impossible to do, but we will be actually able to do it. Let me draw our system, what we have. So we have a resistor here. It is R. It has a resistance value of R. Another resistor like this. And they are all the same resistor. They are all with a resistance value of R. This is R. Yeah, like so. And as I said, we will determine the equivalent resistance of infinitely many resistors. So this system is going. It goes forever with the same pattern. And we will call this point A, this point B. What we are asked to find is the resistance between point A and B, which is, of course, the equivalent resistance of all of our resistors. And as I said, we have infinitely many resistors. So how can we approach this problem? Give yourself a couple of seconds to think about it. Alright, like the way I would do this problem is, I would look at this part of our system. This part right here. What I did actually is, for now, I didn't consider this part, right? And if you don't consider that part, if you look at the part inside the circle, I'm not sure if that is really a circle, but if you consider that part, what we have is, well, we have infinitely many resistors as well, right? We just subtracted 3 resistors from infinite resistors, so that doesn't change anything. Which means that the one in red is the same thing as the entire system, the one in blue. So they are equivalent, as to say, which means that if we calculate the equivalent resistance between points C and D, if we calculate RCD, it will be equal to RAB. I hope that this is clear, because as I said, if we just subtract 3 resistors from our pattern of infinitely many resistors, well, it's not going to change anything, right? It is not going to change anything, because infinity is so huge that subtracting 1, 2, 3, even 1,000 would not change anything. So what we have here is this, again B and again A, R, but this time we have, instead of all of those resistors, we have RCD here. And notice that it is in parallel with this resistor right here. And just like I said here, we can call this RAB. So now we are ready to solve for RAB. And what could we do? Well, what we could do is, instead of these 2 resistors in parallel, we can write their equivalent resistance, which is just equal to this. If you watched my previous videos, you know that this is the case. If you didn't watch them and you don't recognize this formula, well, go ahead and watch those, please. So let me draw it one more time. We again have our point A, resistor R, our equivalent resistance, this thing. Still we have R, and we have B. Now, we have 3 resistors in series. So to find their equivalent resistance, we will add their resistance values. But I want to do that on another page. We are actually done with, all that analyzing the system and making interpretations, making clever moves. We will just have basic arithmetic now, basic algebra. So here we go. The equivalent resistance between A and B, we represented that as R AB is equal to. And as I said, we will add these values. We will add the resistance values because our three resistors are in series. Oops. Yep. So we have R plus, what was it? Yep. Divided by R plus RAB. And we have another plus R, which we can just put a 2 for it here. But let me get space. Alright, so we put a 2 there. And what can we do now? What can we do now? Well, let's just equalize our denominators. So this is, 1, 1, and I'm going to multiply this with R, and this one with R plus RAB, so that we have RAB squared plus R times RAB is equal to 2R squared plus 2R AB times R, and plus R times RAB. Check my algebra there and make sure that you get the same value. This is what we have, and I simply divided by the common denominator, so I'm not writing that. And what we can do here is these cancel, and let's get all our terms on one side. Let's combine them on the left side. So we have this. Alright, great. And now what we need to do is we will just solve for RAB. We will factor. But as you can see, it is hard to factor. So we will use the quadratic formula, which I have proved in another video. So if you haven't watched that, please go ahead and do so. But anyway, RAB is equal to negative this part, so it becomes, oops, not that part, right, these two, the coefficient of our RAB term. So we have 2R, what am I doing, 2R plus or minus the square root of B squared, which is 2R in this case, negative 2R actually, squared, minus 4A, which is just 1, right, 4A, and then C, which is this. Great. And we divide all that by, well, by just 2. And what does this give us? This gives us, let's do it below here. This gives us, we simplify by 2, we have R plus or minus, let's see, what does the inside of the square root equal to? We have 4, actually let me do it here. We have 4R squared plus 8R squared inside of the square root, so we have 12R squared here, which will give us 2R square root of 3, yep. And we divide by 2 so that we have this. And let me erase this part real quick. Of course, I hope that you are checking my math as I go along. You should always check someone's math. You should trust no one when it comes to mathematics. And this is our solution. However, this is our mathematical solution. If we return to our system, we know that we are talking about a physical quantity. We are talking about the resistance value of a resistor. So we can't have a negative value, right? If we subtract R times the square root of 3 from R, we get a negative value. So we actually do not include the negative solution. We just write R plus R times the square root of 3, which can be written like this if we factor out r. So this is the solution. This is the equivalent resistance value between points A and B, where we had infinitely many resistors. And what this means is, if you were to have this pattern here, one resistor here, one resistor here, one here, one here, one here, like that, if you repeat that, and let's say instead of infinitely many resistors, you have 1,000 resistors, well, you would know that the resistance value will be close to this. If you have 2,000, it will be even closer. So it will converge to this value, so to speak, if we use a mathematical term. And this is it for this video. I hope that you enjoyed this video. If you have any comments or suggestions, please go ahead and ask them in the comment section. I hope to see you in another video. Until then, take care.